can continue a little bit about the blockchain. So here it is. So basically, it's just a list of transactions, right? Let's say there have been a lot of transactions already. We're now on page 62, whatever, the balances, some more transactions for this page. After these transactions, let's say we have new balances. The game continues, 62 pages, page number 63, new balances, new transactions, and so on and so forth. And then in computer science, different areas use different terms, right? In computer science, often a list, a collection of something is also called a block, okay? It's not nothing new, not coming from 2009. From a while ago, in computer science, they often use a block as a term for a collection of something. And as you see, this is just a collection of transactions, so they could also call this a block of transactions. And as you see, they are going one after another. We fill out one page of all of our transactions, just like we have over here, right? Once it's full, we just take another page and continue, right? So the pages go one after another, just like chain links in a chain, right? So blockchain is just a list, pages and pages of transactions going one after another. Okay, looking something like this. In reality, it looks something like this. I will show it to you right now. Okay, so if we just go to blockchain.com, it's not a company who created blockchain. The first ever blockchain was created by an anonymous person. We don't know who it is. It's just a company who was lucky enough, to get this domain, blockchain.com. If we go to the Explorer, okay, if we go to the Explorer, not Exchange, Explorer, and scroll down a little bit, we will see that unlike my example, where we have page 62, page 63, in the actual Bitcoin blockchain, but there are different cryptocurrencies as well, right? In the actual Bitcoin blockchain, we are already on the page 703,616, right? And if you click on that page number, right? Let me zoom out a little bit, you will see a list of transactions. This is just a list of transactions, and it goes, as you see, for more pages, that's still within one block, right? Usually a block can fit anywhere between 600 to 800 transactions. And as you see, if we actually look at the blockchain, we don't see the actual name of the person. Adam sending this much Bitcoin to Bob and this much Bitcoin to Kathy, right? Actually, on the blockchain, the transactions are pseudonymous. Pseudonymous is a little bit like anonymous, right? If you are anonymous, then that means people don't really know your name, right? If you are pseudonymous, you use a pseudonym, right? Like if I want to write a book, but I don't want to use my name, maybe I want to use some fancy name, I don't know, Spitfire Dragon or something, whatever. Wow, look at the author's name, Spitfire Dragon wrote this book, right? That would be my pseudonym. So instead of actual real names, what we have here, instead of a pseudonym, is an address. This is called an address. Okay, so this address sends this much Bitcoin to this address, and this much Bitcoin to this address, and so on. All of the transactions. Let's go to another page within the same block, right? Again, this guy, that's just an address. We don't know who it is. It's actually BC1QTMDDX, whatever. Sends this much Bitcoin to this address, this much Bitcoin to this, and so on, right? So this is how you can actually verify the transactions did go through, right? So if I tell you, hey, pay to my address over here for the services or products I gave you, right? And you make a payment. Later on, if there is a dispute, we can check on the blockchain. Blockchain is just a list of transactions distributed in over 10,000 places all over the world, right? So how do we actually look at the blockchain? Well, there are apps, there are software that allow us to look at the blockchain. And this website is just a software, it's just an app that allows us to look at the blockchain. Okay? Or, as I said, you can start up your own blockchain.
Is there any way to know the reason for these transactions, or that's never?
No, the blockchain itself doesn't show the reasons, but there are companies that do analytics. For example, if we look at will see that if we look at this transaction, for example, right? This guy paid in total this much, right? And out of that 6.9 bitcoins, 0.0996 went here, and the rest went here, right? But actually, if you compare this address and this address, it's the same address. So he sent to himself part of it. Only a small part actually went to somebody else. And then, if let's say, for example, we know that this is a public address of some exchange. For example, there are many exchanges all over the world, right? Just like stock exchange, right? There are cryptocurrency exchanges. Coinbase is one of the largest cryptocurrency exchanges in the US, right? In Taiwan, we have BitoX. So if you go to bitox.com, you'll see this is a local Taiwanese exchange. Here. As you see, it shows the price of Bitcoin right now close to 1.4 million NT, right? So there are exchanges, and the addresses, often addresses of these exchanges are known, right? Let's say if I'm a regulator, government regulator, I might request the address of the publicly listed exchange. I can't request the address of an individual, right? So if I know, for example, right, that this address is a known exchange address, right? Then I would know, oh, this guy is sending money to the exchange. Otherwise, if I don't have a background information for the addresses, then I might not know, right? And then in future, if I see money coming from this address to another address, even though it's not the same, right? I might assume that perhaps this address and this address are the same person, right? You know what I mean? Or if, let's say, anyway, there are these kind of analytics, much more complex AI-based analytics of all of this data that can happen, but the blockchain itself doesn't actually give us the names or the reasons for the payment. Okay? So now it's a very big deal, this blockchain analytics. It's a huge deal right now because governments are trying to fight illegal money laundering and stuff like that, right? There are huge grants right now for blockchain analytics, especially for Monero. Monero is another cryptocurrency which is focused on privacy. It shows much less than the Bitcoin blockchain. So the whole blockchain over here for Monero is encrypted. And it's really, really hard to crack. Nowadays, there are millions of dollars in government funding to try to crack Monero. So far, it hasn't happened. Anyway, that's to answer your question. Going back to our class, which we have to finish. As you see, blockchain is just a list of transactions. That's all, right? Pages and pages of transactions. Looks like this. And because right now we're already on page 3,616, and each page is a couple of megabytes, the whole blockchain, Bitcoin blockchain, weighs nearly 200 gigabytes or something. So if I have a wallet over here on my phone, I can't fit 200 gigabytes of data on my phone, right? So there are different types of Bitcoin wallets. Okay, that's moving on over here. Different types of Bitcoin wallets. Where are we? Here. There's a full node wallet that downloads the whole blockchain. This is an example of a full node wallet. This wallet, this list, this blockchain has all the transactions that have ever happened, right? In our small little game, right? In our small little game, there were 4 gamblers, right? Each not trusting each other, so each taking a copy of the transactions, right? This would be a full node. Remember, one of the copies in the network is a node, right? It's a full node. But would it be possible for a 5th person to play with us, but not actually writing down the transactions? Would that be possible? Why not? If he kind of relies on us to keep track of transactions, if he doesn't really want to, if he trusts us enough, right? Right? So that's the same here, right? On a phone, you can download a wallet, right? And that would be called a lightweight client, lightweight wallet, where you can participate in this game, but you don't actually write down all the 200 gigabytes of data of all of the transactions that have ever happened on the blockchain. So there are different types of wallets based on how much data they use, such as full node wallets, or lightweight wallets. In the case of lightweight wallets, if this is a new gambler who's playing with us without taking track of transactions, right, he could verify with three or more people, just to make sure there is no disputes, right? So that's what lightweight wallets do. They connect automatically to full blockchain nodes, and not to one, so that to eliminate any kind of problems, right? They randomly connect to around 12 out of 10,000, right? So that's a type of wallet, and then that's based on how much data they download, and also based on how they look like. There are different types of wallets. There are, for example, web wallets, which I don't really recommend because a website can be hacked, right? Web wallets examples, bitgo.com, zappo.com, coin.space, all of these can be your web wallets. It's a Bitcoin wallet on the internet. So you create an account on the web page, right? And then keep your coins there. I would not recommend it because I don't know how good is their security, right? Perhaps they could be hacked. That's a web wallet. Another type of wallet is a desktop wallet. That's much better. That's downloading the app, and we are going to do this next week. Okay, you already have seen how easy it is, right? Just downloading the app on your computer, making sure you don't have viruses on the computer, that's all, right? So that's a desktop wallet. There are also mobile wallets. Wait, still here. There are also mobile wallets, of course, a wallet on the telephone, right? That would be a lightweight wallet. The good thing about mobile wallets is that usually phones have much fewer viruses than desktop computers, because desktop computers have admin access, right? You can install new software and things like that without clicking too much permission buttons, whereas on the phone, the user doesn't actually have admin access as much, okay? Anyway, mobile wallets are generally a little bit more safe than desktop wallets because it's more likely to have viruses on the computer rather than on the phone. And the safest option is hardware wallet. It looks something like this, some kind of a USB device, but it's not a simple USB stick, right? Actually, it is a wallet that will keep bitcoins for you. It doesn't keep your project files or your favorite cartoons, right? It's a wallet with PIN codes and things like this, as you see. So that's the safest. It can only do Bitcoin. It cannot download anything else. That's why it will not have a virus, right? Computer can download anything. That's why it might also download a virus, right? So different types of wallets. Okay. Yeah, I think I kind of went a little bit too fast with that, but I think that's enough for today. We're going to talk about wallet recovery and actual practice with the wallet next week. I want to leave that for next week, otherwise I don't know what to teach you. Questions? So, on Moodle, I announced that for weeks number 3 and 4, you guys will have to bring a computer. As I said, I've changed my plans since summer, right? I thought you guys, each of you, are going to do some coding, programming, new things, pretty difficult things. I thought this is a second year class. But because of the freshman class, I changed my mind. We're not going to do that. Instead, we're going to practice a little bit with wallets. And I've tested, you've tested, right? Looks